Okay, now we took an idea. We took an idea. When a star like this, it was not the core of our subject. By chance, this happened. When a star like this explodes, the meteorites that come for another star explosion, it comes from a death of a star like this. I put this video so that you know the meteorites from where come. When a star dies, explodes, these meteorites come from dead stars, okay? Look what it's telling. And we send down iron. God is telling, we send down. We know the iron is come from the ground. Yes, Mr. Avedis? Here it's telling, the iron we bring from the heaven. Okay, we will check this. Is the iron from heaven or from the earth?
Broken into pieces, called plates. 4.6 billion years ago, a continual wave of meteorites pounded the molten Earth. Each strike brought with it more rock, making our planet bigger and scattered.
Look at the Earth, the meteorites, not all of them had iron. It must explode a big star so it produces iron. Look what happened.
Carrying metals over the surface.
A big clump of iron came from a dead star like this, Wolf-Rayet, and it hit our Earth. The iron came from heaven.
Then, a giant asteroid struck. Its massive iron core didn't stop on the surface. It sank towards the center.
Because of this we have iron core in the Earth, because it was hit from iron meteorite. And the moon, it doesn't have iron core, because when it splattered, this splattered formed the moon.
And it attracted all the Earth's metals to it as it went. The asteroid's lighter, rocky debris went spinning around the Earth. The fragments were drawn together by gravity. Within a year, they formed our moon. That's why the moon has no metal at its core. And it's why metal is rare in the Earth's crust. It arrived much later, in meteorites from outer space. If we want much more metal, we must go to the Earth's core. It's made mostly of iron and nickel, but 1% is gold. That may not sound like much, but the core is so vast that its gold could cover all the land on Earth.
Okay, now you took an idea that the iron from game outside. We will see how the iron came, how the iron formed. This is the periodic table. In another episode that we made, we spoke about the suns. Each sun makes an element. For example, this is element hydrogen, helium. It goes up numbers till uranium 92. Where is 92? Here somewhere. Okay? Our sun, it makes till oxygen and carbon. It cannot make more. They fuse together the atoms. The sun, it gets its energy from fusing elements together. From hydrogen fuses together, it becomes helium-2. Helium-2 fuses together, it makes beryllium. Like this, the elements are formed. But when our sun, for example, the heat is only can make carbon. It cannot make higher elements. It must be big sun, like Wolf-Rayet, so that it can make higher elements. But there is something strange about iron, something strange. when the stars are strong, making more stronger than our sun, making more elements like this phosphorus silicon, when it starts making iron, the star, below iron, when it's melting, it's giving energy to the sun. When it starts making iron, the iron takes energy in inside, because of this explodes the star. Wolf-Rayet now is making iron. And iron, it doesn't give energy out, it takes energy in, it explodes, and it sends us iron. Okay? It's a small explanation. You understand, Mr. Costi? Or difficult little? Okay. You took a small idea now so that we continue. Here they will explain the same so that you understand. Maybe they explain better than me.
Iron is the element in the periodic table of Mendeleev that happens to be, from a nuclear point of view, most stable. What I mean by that is the following. If I take two protons and crash them together, I can make deuterium, which is what the sun does in abundance in its core, and then I can crash deuterium together with more protons, I can build up helium, then I can build up carbon, magnesium, oxygen, all the intermediate weight elements in the periodic table up to iron. And every time I do that, I get energy out. Those reactions are exothermic. I get more energy out than I put in. And so that's a way of feeding energy into the core of a star.
Iron is a problem. When a star tries to fuse iron, iron actually takes energy in when it fuses. So if you fuse iron, you're actually absorbing energy instead of letting energy out to support the star. That's bad. A star will die a couple milliseconds after it begins to form iron in its core, because now instead of energy supporting all that gravity, it's taking it up and the star collapses. And this collapse is the precursor to what we call a supernova explosion, because the collapse is so violent. The core just collapses and all the material of the star collapses around it. And the temperatures inside that go so high that they fuse every other single chemical that we know of in the universe in an instant, in a millisecond. So for example, gold. I always like to think of the gold in my wedding ring. Gold is a more complex element than iron. It's actually a heavier element than iron. And the only thing in the universe that forms a gold atom is a supernova explosion. So when you think about things like gold or silver, or in fact even the iron in your blood, that iron was formed the very instant a star died.
Okay, just to summarize, when a star is making iron, it explodes. The moment it's exploding, it makes the gold, because of this gold is little, because it has made, the moment it explodes, because of this gold is rare. Okay, you took a small idea how iron is coming to us. Now I gave you a small explanation about this so that when I speak about comets, asteroids and meteorites, you understand. I make a small example so that you understand. Look, he's telling some of them we sent Hasiba. We sent among them storm of stones. We know that the stones exploded in the sky. It's coming to storm down. Some of them we got the shout. Some of them it's exploded in the air. And some of them khasafna fil ard. We open the earth swallow. Okay, we have two things now. We have one that it's raining stones. One we have a shout. Two kinds of meteorites. One shout, one stone hitting the earth. We have two things now. Okay? We have two things. A stone coming at the earth, and there is one stone exploding like a shout. We will check this now. This is the subject. We will see what is a comet.
In this What Is video, we're going to take a closer look at asteroids. Asteroids are small planetary objects orbiting the sun. Their hard, rocky bodies differentiate them from
What is the difference between a comet and an asteroid?
Comets, which are made of small rocks, dust, and ice.
Comets are made of ice, water.
Asteroids range in size from a few meters across to objects large enough to trap smaller asteroids in their gravitational pull, like moons orbiting a planet. Asteroids lack the gravitational force needed to round out like planets, so most are irregularly shaped. They have no atmospheres and are not geologically active. Hundreds of thousands of asteroids exist in
Hundreds of thousands, okay?
the solar system, most occupying an area between Mars and Jupiter.
This is the asteroid belt. Anytime a small stone 10 meter, one country is gone.
Called the asteroid belt. Despite their numbers, the combined mass of all solar system asteroids only equals the mass of the moon. Asteroids that cross the Earth's orbit are called near-Earth asteroids.
There is near-Earth orbit asteroids also.
Astronomers have discovered approximately 4,500 near-Earth asteroids, including up to 1,000 with 1 kilometer diameter.
And there is 1 kilometer each orbiting. And with 10 meter we saw what it did. There is 1,000 stones orbiting the near Earth, 1 kilometer each one. Very frightening this.
Diameters. At least one asteroid with a 4 to 10 meter diameter hits the Earth every year. Impacts with large asteroids have triggered planet-wide extinction events several times in the Earth's past. The last mass extinction event wiped out the dinosaurs. A similar cataclysm could seriously test humanity's ability to survive. So astronomers track large asteroids capable of causing such impacts. Going back to the beginning of the solar system, asteroid impacts helped grow planets, adding to a forming planet's mass while clearing its planetary orbit. An impact with an enormous asteroid as large as Mars ripped a chunk off the early Earth, creating the moon. Asteroids have changed little since the beginning of the solar system, over 4.6 billion years ago. Their composition could teach us much about those early years. As for the future, rare minerals found on asteroids can provide raw materials for space exploration. And that's the rock-hard truth about asteroids.
Very good. Okay, we will watch now another verse. This is very good. This is I think the Scientologist who believes in aliens would like it. Here it's telling they may not listen to the exalted assembly and are pelted from every side, except one who snatches some words from the aliens, and they are pursued by a burning flame. What is this? Very, very strange. They cannot listen to the exalted assembly. Yani there are some, the jinn is talking about the jinn. When they go to the atmosphere, they want to listen to the aliens, the Mala al-A'la, but they are thrown with the shihab al-thaqib, like fire, shooting stars. What is this? What it's speaking about? We will check this.